Chapter 11, Section 4, Fundamentals of Probability. The objectives: compute theoretical probability, compute empirical probability. Probabilities are assigned values from 0 to 1. The closer the probability of a given event is to 1, the more likely it is that it will occur, as shown in the diagram at the left. The closer the probability of a given event is 0, the less likely that event will occur. An experiment is any occurrence for which the outcome is uncertain. The sample space is the set of all possible outcomes of an experiment, and we denote this by capital S. The event is any subset of a sample space, and we denote it with a capital E. The sum of the theoretical probabilities of all possible outcomes is 1. Computing theoretical probability. If an event E has NE equally likely outcomes and it has sample space NS equally likely outcomes, the theoretical probability of event E, denoted by PE, is the number of outcomes in event E divided by the total number of possible outcomes. Example 1, computing theoretical probability. A die, that's singular for dice, is rolled once. Find the probability of rolling A, a 3, and B, an even number. Solution. The sample space is S is equal to the set containing 1, 2, 3, 4, 5, 6, because the die has 6 sides. A. There's only one way to roll a 3, so N of E is equal to 1. The probability of 3 is the number of outcomes that result in 3 divided by the total number of possible outcomes. So this would be 1 over 6. For B, rolling an even number. Rolling an even number describes the event where E is equal to 2, 4, or 6. This event can occur 3 ways. So the number of outcomes that result in an even number divided by the total number of possible outcomes would be 3 over 6, which reduces to 1/2. Example 2, probability and a deck of 52 cards. You are dealt one card from a standard 52 card deck. Find the probability of being dealt A, king, B, a heart. The probability of a king. The king outcomes over the total possible outcomes. There's 4 kings in a deck. You've got 52 cards in the deck, so it'd be 4 over 52, which reduces to 1 over 13. The probability of a heart is the heart outcomes divided by the total possible outcomes. There are 13 hearts divided by 52 cards, which reduces to 1/4. Empirical probability. This applies to situations in which we observe how frequently an event occurs. The empirical probability of event E is the observed number of times E occurs divided by the total number of observed occurrences. In example 3, we're going to compute empirical probability, and we have a table showing males and females and whether they're married, never married, divorced, widowed, and then the totals. If one person is randomly selected from the population described above, find the probability that the person is female. The solution: the probability of selecting a female is the observed number of females, 124 million. Now, they didn't tell us this was millions, but now they do. So 124 million, that's the total number of females as shown in the table, divided by the total number of U.S. adults, which is 242 million. So the probability of female would be females divided by total number of adults, or 124 divided by 242, which is approximately 0.51. That concludes this lesson.